Test Review 8, covering Module 8, Logarithmic Functions. Question 1. Write each equation in exponential form. So for this one, we take the base of the logarithm, we raise it to the 5th power, and that's going to equal 243. Next one, log base 4. So we take the 4, raise it to the 5/2 power, and that's going to equal 32. Question 2, write each equation in logarithmic form. So here they're giving it to us in exponential form. So we do the same thing. We take the base, so that would be log base 27 of 9 is equal to our exponent of 2/3. Next, we have log base 1/7 of 1 over 343 is equal to our exponent of 3. Question 3. The pH of a substance can be represented by the equation y equals log base 10 of 1 over H positive, where H positive is the number of hydrogen ions. Find the H positive value if the pH of apple juice is 3. Round your answer to the nearest 10,000th. So we're going to take our equation, and I'm just going to flip it. So I'm going to have log base 10, and I'm going to expand it. So that's log base 10 of 1. When it's division, we subtract it to expand it, and then this will be log base 10 of H positive. And this is going to equal our y, which is our pH value, and our pH value is 3. From here, we can do a little bit of simplifying. Log base 10 of 1 is 0, minus log base 10 of H positive equals 3. And I need to get this logarithm by itself. Right now there's a -1 in front, so the opposite of multiplying by a -1 is dividing by a -1. And now I'm left with log base 10 of H positive. That's going to equal a -3. And now we can rewrite this in exponential form. So that's going to give us base 10 of -3, or raised to the -3 power, is going to equal our H positive. We need to put this as a decimal, which would be our H positive is going to equal 0.001. Now it says to the nearest 10,000th, but because this one is an exact answer, we would just keep it at 0.001. Question 4. Solve log base 9 of x equaling 3/2. So the easiest way for this is write it as an exponential. So it'd be 9 raised to the 3/2 power. And that's going to equal our x. So the square root of 9 is 3. And then 3 cubed is going to give us 27. Next, log base 8 of 2/3 is going to equal x. So here we have the cube root of 8 is 2. 2 squared is going to give us an answer of 4. Question 5. Solve the equation, check for extraneous solutions. Now if the bases of the logarithm is on each side are the same, that means everything else is going to equal each other. So this gives us 2x squared minus 20 equals 6x. We want to get everything to one side with a positive x squared. So I'm going to subtract 6x on both sides. And this is going to give us 2x squared minus 6x minus 20. That's going to equal 0. From here we can factor out the greatest common factor. And the greatest common factor is 2. So if I factor out a 2, then I'm left with x squared minus 3x minus 10 equaling 0. And this 2 on the outside, the greatest common factor, has no meaning right now. So if I factor what I have left in the parentheses, I would have x minus 5 times x plus 2. Because I had to find out what do I multiply to get -10, but add them together gives me -3, and that's a -5 and a +2. Now if I make both of them equal to 0, I can only use find logarithms of positive numbers, and because the coefficients of both my x's in the original problem are positive, I can only use positive x values. And the only one that's going to give us a positive x value is when x is equal to 5. So -2 would be extraneous. That would not work if we put that back into the original problem. Let me rewrite this 5 to make it look a little better. Okay, question 6. Use log base 2 of 3 to be about 1.5850 and log base 2 of 5 equaling about 2.3219 to approximate the value of the expression below. Here, so we're going to expand it using the properties of logarithms. So I can rewrite 81 as this would be log base 2 of 3 to the 4th power, because 3 to the 4th power is 81. So then if I use the properties, I can put 4 out in front, and this would be 4 times log base 2 of 3, and they said log base 2 of 3 is 1.5850. So now if I grab my calculator, and we do 4 times 1.5850, we get an answer of 6.34. Next one, we have log base 2 of 625, and I can rewrite that as log base 2 of 5 to the 4th power. And we're going to do the same thing we just did. So I can put the 4 out in front, and that would be 4 times log base 2 of 5 is 2.3219. So I can grab my calculator again, and we have 4 times 3219. That equals 9.2876. So 9.2876. Question 7. Solve the equation to the nearest 10,000th. So when you have a problem where the variable is in the exponent, we're going to undo an exponent by writing it in logarithmic form. So I'm going to put the log of 2.4, and that means this x plus 4 is going to go on the outside. So x plus 4. So I'm just using like the power property of logarithms. And this is going to equal the log of 30. And then I can get the x plus 4 by itself by dividing by log of 2.4. And do that on both sides. And I'm left with x plus 4 equaling log of 30 divided by the log of 2.4. Now you could solve that right away, otherwise I just wait until the very end. So I'm going to subtract 4 on both sides, and I'll do this on my calculator all at once. So we grab our calculator here, and we have log of 30 and parentheses divided by the log of 2.4. And then from there, we're going to subtract 4 from our answer, and we get an answer of a negative 0.1150. So a negative 0.1150. That's to the nearest 10,000th place. Now, if you put it as negative 0.115, that is technically correct, but because they want you to round to the nearest 10,000, to show that we round to the nearest 10,000, we would put the 0 at the very end. Question 8. Express the logarithm in terms of common logs and approximate its value to the nearest 10,000th. So here, it's really the change of base formula. So what I'm going to do is I'm going to put this exponent out in front, and so this is going to be 6 times the log of 3.6 divided by the log of 2. And to the nearest 10,000th, we'll grab our calculator again. So we have 6 times the log of 3.6 Now, if you wanted to do what 3.6 to the 6th power is first and then find the log of that, you may do so. Then I'm going to divide this by the log of 2. And that gives us an answer of 11.0880. So 11.0880. Next, log base 3 of square root of 150. So this is really saying the log base 3 of 150 to the 1/2 power. Now if I do the same thing as what I just did above, I'm going to put this out in front. But instead of putting the fraction half, I'm going to use 0.5. And this will be log of 150 divided by the log of 3. Put this in our calculator. So we have 0.5 times the log of 150, and then we're going to divide that by the log of 3. That gives us 2.2804, so 2804, 2.2804. Question 9. Write exponential to logarithmic and logarithmic to exponential below. So right now, the first one, they're giving it to us in exponential. So to put this in logarithmic form, I'm going to do the natural log of e and the natural log of x on both sides. Natural log of e is 1. 1 times 15 is just 15 equals, actually, yeah, and that'll give us the natural log of x, but we're not solving it, we're just rewriting it. So let me start that over again. So putting it in logarithmic form, so if this is base e, we're going to do the natural log. So the natural log of x is going to equal 15. And here, natural log is base e, so we take e raised to the 8th power. So you write base e to the 8th power. That's going to equal our x. Question 10, write the expression as a single logarithm. So you got to remember our properties of logarithms. So when it's written as addition, that's going to be, put it under 1, it would be multiplication. But first, the number out in front goes as an exponent. So right now I have the natural log of 4 to the 3rd power times 3 to the 3rd power. So I have 64 times 27, which is going to give us the natural log of 1,728. And that's how you would write it as one singular logarithm. Next, put 8 as an exponent on the x, 4 as an exponent on the 5, and we're going to have the natural log of x to the 8th divided by 5 to the 4th. When you see subtraction in an expanded form, that means it's written as a division problem when you combine it into 1. So this is going to be natural log of x to the 8th divided by 5 to the 4th is 625. Question 11. Solve the equation to the nearest 10,000th. So here, we're now solving for x. So to get the x down, we're going to put that out in front and find the natural log of both sides. So the natural log of e equals the natural log of 5.8. The natural log of e is just 1. 1 times x is x. And this is going to give us the natural log of 5.8. And x is going to equal, grab our calculator, we do the natural log of 5.8. That equals 1.7579. So 1.7579. That's to the nearest 10,000th. The next one, we have natural log of 3x plus natural log of 2x equaling 9. We want to put it under 1. So this would be the natural log of 6x squared equaling 9. Now to undo this, this is already a natural log form. We need to put it in exponential form. So this is base e. So we're going to take e to the 9th power, and that's going to equal 6x squared. From this point, to get x squared by itself, we're going to divide by 6. And so now, right now, I have e to the 9th power divided by 6 equaling x to the 2nd power. Now to undo a square, we find the square roots. And remember, when we find the square root, there's a positive and a negative root. But because we're dealing with logarithms, we can only have numbers that are positive to find a logarithm. So x is going to be about, and on my calculator, I'll show you how you can do this all in one step. We're going to do parentheses, and then we have, actually not parentheses, let me clear that. So I hit second x squared for the square roots, and we're going to do second natural log for base e raised to the 9th, end parentheses, and then I'm going to divide that by 9, end parentheses. And the reason why I'm putting the other end parentheses is because I'm finding the square root of e to the 9th divided by, this should be 6. So divided by 6. Then after that end parentheses, then we hit enter, and it gives us 36.74933997. So to the nearest 10,000th, that would be 36.7493. So 36.7493. So 7493. Just want to verify that that's correct. So that one is correct. Next, question 12, write the expression as a sum or difference of logarithms or multiples of logarithms. So it's really just asking us to expand this. So it's written as a division, so I can write it as a subtraction problem expanded. So this would be the natural log of 8 minus the natural log of 25. Or if you want to be a little more, if you want to make it a little bit more complex, you can do 3 times the natural log of 2, because 2 cubed is 8, minus 25 could be 5 squared. So this would be 2 times the natural log of 5. But either way, either the top or the bottom would work for your answer. And our last two questions. Janie's bank pays 2.8% annual interest compounded continuously on her savings account. So compounded continuously is the key phrase. What will be her balance in her account after 15 years? So for this one, we're going to use the PERT formula. So A equals P times base E raised to the RT power. So we're solving for A when the principal amount is 2,000 times base E raised to the 0.028. Remember, put that percent as a decimal, and then we're going to multiply that by 15. So we're going to do this all on our calculator. So we grab our calculator here, and we have 2,000 times second natural log, and we have 0.028. And then we're going to multiply that by 15, end parentheses. That gives us an answer of $3,043.92. So A equals $3,043.92. Question 14. In the year 2000, the population was 6.124 billion. The function f of t equaling 6.124 e raised to the 0.0123 t can be used to determine the population in billions in t years after 2000. To the nearest hundredth of a year, how many years will it take for the population to reach 7.5 billion? So we're going to put 7.5 in for f of t. So 7.5 equals 6.124 times e raised to the 0.0123 t. Now to get that exponent down, we need to get the exponential by itself. So we're going to divide this by 6.124. We're going to do this on both sides. And I'm going to wait to the very end to put this on my calculator. So if I have the exponential by itself, to get base e, get rid of base e, I have to do the natural log of both sides. So that would be the natural log of 7.5 divided by 6.124 equals the natural log of e to the 0.0123t. Now the natural log of e undoes each other. Now I can get the t by itself by dividing it by 0.0123. Divide that on the left side. And we can solve for t to the nearest hundredth. That's 2 decimal places. So we grab our calculator. And we have natural log of 7.5. 7.5. We're going to divide that by 6.124, end parentheses, and then we're going to divide all of that by 0.0123. That gives us an answer of 16.478. That 8 tells us to round the 7 up. So this would be 16.48 years. So 16.48 years. So as a quick review on working with logarithmic functions.